All right, guys, so we obviously did not get as far ahead as I thought we would today. So I am re-recording this lesson to re-upload into Kiddom. So today we got textbooks. So again, distance learners, if you want a textbook, email me and I will put you on a list. I have not sent the email out yet for y'all to come get them. I will try to do that today before I leave. Hopefully I get to it. But today we are going to be learning a lot about some absolute value functions and transformations. But first, we are going to review transformations from linear functions. So linear functions are a line, exactly what is up on the screen that y'all see right now. So the graph of f of x equals x is shown. Graph each transformation. So some people remembered some stuff, some people did not, but this plus 5 right here. So what? Hang on, I'm going to put my computer into tablet. But so that plus 5 means that we are going to transform this graph of f of x. We're going to transform it into g of x, and we're going to go up 5 units. So you'll go to a point on the graph. So I'll use this point first, 0, 0, and you're going to move up 5 points. So 1, 2, 3, 4, 5. I'm going to draw a little line. Probably work better than dots, as I've figured out. And then I'll look at 1, 1, and I will again go up 5. So 1, 2, 3, 4, 5. And then I'll do negative 1, 1, and again up 1, 2, 3, 4, 5. So for on assignments and stuff, for me, I need you to have at least 3 points moved, and you always need to have the arrows on the end of your lines because they go on forever and ever. All right, so let's now look at h of x. So we have this negative 3 over here. So how this one went up 5, this one is going to go down 3. The negative is what makes it go down. If it's positive, it's going to go up, and if it's negative, it is going to go down. The new one on this h of x is this 2 out front. So we're doing 2 times f of x. So that is going to affect the slope of this line because we can always replace f of x with just x. So this is really just changing the slope of our line times 2. So we are going to stretch our graph out, and it'll be by a factor of 2. So we can bring this. So if we're moving down 3, I would take my origin point right here and move it down 3. So 1, 2, 3. I go like that. I think it may be steep enough. So now I'm going to move down 3, and then I know that I'm stretching it by 2. So my slope is going to be 2. And our slope is our rise over our run. So, and this is obviously a whole number, so we are going to be able to put a 1 beneath it because 2 divided by 1 is still 2. So we're going to rise 2, and you always run to the right. So got a point there. And then again, we'll rise 2 and run 1. And since our slope is positive, we know we're headed in that direction. Perfect. We did skip this one in class. If you would like to try it on your own, you're more than welcome to, but we did skip this one in class. Our learning goals for this lesson were that I can use technology to explore transformation of absolute value functions. I can graph absolute value functions and transformations of absolute value functions. I can explain what transformations, sorry, I'm getting tongue-tied, are occurring from the function equation, not a graph. So that's everything that we're going to try to get covered by the time we finish this lesson. So the absolute value of a number is its distance from zero. So distance from zero. Something very important is distance is always positive, always positive. You cannot go negative distance. And as you'll hear me say a lot, so whenever we are discussing the absolute value, it is indicated with vertical bars that are shown right there, and it is read as the absolute value of -4. So that's how I expect y'all to be saying it in class too. It's not the answer is -4, it's the absolute value of -4. So for example, we're going to determine the value of these expressions, and let's look at -2 on a number line. So we have -2, -1, 0. Go ahead and throw a 1 up there. So how many units is -2 away from 0? So we have 1 right here and another 1 right there. So it's a total of 2 units away. So therefore, our answer is going to be +2. Similar situation down here, if we were to add a 2 out here and extend that number line. What is this one green? So 1 and 2. So again, it is still 2. All right. So whenever we're taking the absolute value, if there is more than one number inside the absolute value bars, you need to solve that down to one number. So for example, with C, we have 1 minus, with the absolute value of 1 minus 2. And so that is going to create the absolute value of -1. And the absolute value of -1 is +1. Then down here at D, another way we could rewrite the absolute value is the absolute value of -3 plus 5. And then close out our absolute value bars, because a minus negative can turn into a plus, which ends up being +2, the absolute value of +2. And then our final answer is +2. Over here at E, we get the absolute value of -6, and then we get 6. Continuing on, just continue to solve what is ever inside your absolute value bars until you are down to one number. So for F, what is anything times 0? It is the absolute value of 0 in this case, but it is 0 times 4 is 0, and the absolute value of 0 is 0. We are measuring a distance away from 0. So 0 is 0, distance is away from 0. It didn't go anywhere. Another way you can write this, if you would like, would be 12 in the division symbol, -3. And 12 divided by -3 is -4. So we have the absolute value of -4, which would then lead us to our final answer of 4. Over here, we have the absolute value of -2, which ends up giving us 2. And there you go. So some observations about the absolute value expressions you and your classmates modeled on a number line. I forgot to delete this in the PowerPoint again. We did not model it on a number line, but distance is always positive is pretty much what we came up with today. Someone did even point out to me that most of the answers were even. So 4, 2, 2, 6, and 2 and 2. So there's only 1 and 0 were the odd mans out today. But distance is always positive, so absolute value is always going to be positive. We're going to skip this one as well. So we are now going to start graphs of absolute value functions. So we're going to record the coordinates of the functions in the table. So just a little review. So f of x also stands for y. So y and f of x are the exact same thing. So if we're looking at x, where x is -9, our y value is going to be -9 because technically x equals y. So then we'll have -6, -4, -1, 0, 3, 5, and 8. And then on the final column, we're doing f of x equals the absolute value of x. So we will have +9. Here, I'll even write that in there, which we did in class today. So we are completing the absolute value of -9, which gives us +9. And if you need to write that all the way down, go for it. 6, 4, 1, 0, 3, 5, and 8. And these are the pages directly from the textbook just about. So if you want a textbook, please email me, because this would probably be easier to do than have to write down all this information. And you're probably having to pause this video, which I am sorry. On the next page, we are going to graph these points. I have them written down on a piece of paper next to me, so I have them, and hopefully you have them written down as well. So I'm going to sketch these. If you please would plot the points, it'd make me really happy. But f of x equals x is roughly our straight line across our graph. And I'm going to label this one f of x equals x, so I know which one I'm looking at here in a minute. So the next, I'm going to plot f of x equals -x. And again, I'm going to roughly sketch this, but on your paper, make sure you're plotting the actual points. And this is our f of x equals the absolute value of x. So we're always positive. The absolute value graph looks like a V, and half of it is shared with the f of x equals x. If you don't see that, I'll highlight it really fast. So see how it's right on top of each other right here? Because they're the exact same graph in that quadrant. Okay, so now we are going to look at when f of x equals -x. So we're doing -1 times all of our x values, so we are going to pretty much just flip the signs. So we'll have 9, 6, 4, 1, 0, -3, -5, and -8. And then we're going to take the absolute value of -x. So we are going, there's two ways you could do this. So you could take the absolute value of these numbers right here, because those are -x, or you can do the absolute value of -9, which you would end up getting the same answer of 9. Or if you did it down here, you would take the absolute value of 6, which would be 6. So that one's from there, and that one's from all the way across there. So this one will be +4, +1, 0, +3, +5, and +8. And then on the next slide, we're going to graph this. And again, I have these written down on a sheet of paper. So, and again, I'm going to sketch these, but on your notes, please try to get the exact points. So we in red, yeah. So this is f of x equals -x. I'll do it in blue. And then this is the absolute value of -x. So now on this graph, they actually are sharing this quadrant as being the exact same. So now we are going to consider the three absolute value functions. G of x, which we have graphed several times now, right here. And then C of x equals the absolute value of x plus 3. And if you remember back at our warm-up, whenever we were reviewing transformations, we had a positive 5, and so it went up 5 units. So maybe this will take us up 3 units, and maybe d of x will take us down 3 units. We will see here in a second. So for this activity, if you have your calculator, there's instructions here on how to do it. The graphing calculator instructions are right here. And then Desmo's instructions are right here. So you can choose whichever one you'd like, but please use one or the other. So when using technology to graph the function and sketch it, oh look, there we go. We're going to describe some of the similarities and differences between the three graphs. So one of the similarities that hopefully you see is that these are all still in a V shape. The absolute value graph will always look like a V. It's the best way to find it. If it looks like a V, it's an absolute value graph. One of the differences that we discussed in class was that this one crosses the y-axis at -3. Let me put this in red. -3. This crosses the y-axis at 0, and this one crosses it at +3. So we were right. We did move up 3 and down 3. We did guess correctly. Go us. So here's also a very important statement. So recall that a function t of x of the form t of x equals f of x plus d is a vertical translation of the function f of x. The value, absolute value of d, describes how many units up or down the graph of the original function is translated. So very important that that plus d on the outside of the function is a vertical translation. So we will be going up or down, so when d is greater than 0, we go up because it is a positive number. And when d is less than 0, we go down because it is a negative number. It's kind of the best way to remember those two. So this is very similar to your homework. I even worded it the exact same way. So look here when you have a question later about the homework. So each point, x comma y on the graph of g of x becomes the point blank on f of x. So our x values really didn't change, which we can go back and look at. So our x values really didn't change. We still have all these same x values. But as you can see, our y values did change, which here, and I'll even draw the points on here. So we go from 0, 0 to 0, +3, or 0, -3. So whenever we are looking at the points on a graph, x is going to stay the same, but y is going to be plus d. So for example, the absolute value of x plus 3, our points were shifted x, y plus 3. For our x minus 3, which I don't remember which ones they were, but we're going to just call them f of x for right now. These points were y minus 3 because they went down 3 units. And if this was your homework question, this right here is what I would want your answer to be. It'd be one of these. But your homework question has a little bit more to it. So now we're going to consider the absolute value functions. G of x equals the absolute value of x. K of x equals 1/2 x. 1/2 absolute value of x, sorry. F of x equals 2 absolute value of x. And P of x equals negative absolute value of x. I hope I said all this right. So we're going to use technology to graph these. And I used Desmos earlier. So let's get out of here. We're going to discard those for now. Let's go into Desmos. Go to that graphing calculator. I'm going to flip my keyboard out as well. So we had f of x equaled, and you type ABS for absolute value. That's what we get for that one. Oh, I'm going to probably get these wrong. So then K of x equal to 1/2 ABS of x. For that one was almost like we grabbed the top of our absolute value bars and pulled them down. So that's how that one looks. Let's see, what were the other two? 2 of absolute values. Shoot, what was it? J. J of x, 2 ABS of x. So this one, if we're looking at our just regular absolute value function, this one looks like we picked up the sides and pulled them up, kind of squeezed it together. The best way I would know how to describe it. And then our final one was P of x. So in P of x was equal to the negative of the absolute value of x. And that one just flips right over our x-axis, our x-axis. So that is what those look like. So, and here we'll go back into the first. So to recall that a function t of x of the form t of x equals a times f of x, we'll highlight that because that's a very important, that form right there, is a vertical dilation. So it's a vertical dilation of the function f of x. The a value describes the vertical dilation of the graph of the original function, which we'll get into those right now. So whenever a is greater than 1, it is a vertical stretch. And here we'll go back and we'll look at it here in a second. Okay, so computer decided to shut down, but we are back up and going. So we were looking when a is greater than 1, and it was a vertical stretch, I believe. Let's double check that I was on that one. So yeah, when a is greater than 1, and yours says a vertical stretch. So that is our green one. So we make the blue one. So we vertically stretched it up. So kind of would be like taking your two hands on the outside of this absolute value graph and squeezing it all up together. Would be the best way I could describe it. So let's go ahead and go to the next slide. And this is when a is less than 0. And this is a vertical dilation. Funny, I got in here and then I'm going to go right back out to look at our vertical dilation. So this is when a is less than 0. So if a is less than 0, we're going to be looking at a negative number. So there is our vertical dilation. We pretty much just reflected over the y-axis there is what we did for that one. And then our next one is going to be, can I draw one here with this? Fabulous. Let's make it red. So when a is between 0 and +1, I like this better. Maybe this is how I should do the PowerPoints. But I can graph better with this too. Learn it every day. So this one is a vertical compression, which we can go and look. And 1/2 is between 0 and 1. So This one would be if we were to take our hands on the y-axis, and at the top and at the bottom, and kind of squish it down, it would compress it. And that would be what you would get. So I guess we'll finish like this. This looks nice. Yeah, actually, we'll go ahead and finish this one like this. So again, very similar to where we were adding D, we're looking at the points. So, and for these, our X points stayed the same. Oh gosh, sorry. Our X points stayed the same, but our Y values were actually A times the original Y value. That really does not look good. Let's erase that. Maybe if I write it in a highlighter in red. So it'll be A times Y. Oh, that looks just as bad. It's A times Y. Just believe me that there's a dot there. So what I was wanting for your homework was I gave you two equations kind of similar to this, and I want the X and Y coordinates kind of like here. I want them for this function. So for this function, we have our X isn't changing because our X didn't change anything we did today. But we have an A out here. So we're going to have 3X, or not 3X, 3Y. Sorry, guys. And then we also have our plus 8 out here at the back. So we're also going to have our plus 8 here. And then for the graph part of function, all you got to do is just sketch a little graph. I'm going to we'll do 2, 4, 6, 8. We'll call this 8. And I know that my absolute value graph, which is going to be a V, is going to cross my y-axis here. I know that, so I'm going to plot that point. And then I'm just going to draw a very skinny V, because this is going to be a very skinny V because of that 3. We can even go and put this in Desmos, so if you have access, put it in Desmos, or you can put it in your graphing calculator and look at these. And then it'll be even easier to sketch. So that is how your homework needs to be completed. If you were in second period in class today, do what I told you to do in class. And if you already finished the video and the homework that was already posted into Kiddom, you're fine. Just submit that for today's homework. We kind of got a little off today with the bells. So if you have not watched the other video or done the homework, just watch this video and do this homework. All right, guys, y'all have a great rest of your day.